Hey everybody, this is video 10.4.4 and we're going to be solving equations and we will use lots of different methods. This is one of those that you're going to have to be open to looking at it before you jump in to a method. So there's no way for me to say all of them go this way or all of them go that way. You're going to have to be prepared to use any method. I'm going to show you some examples and some strategies, and then as you work through the practice when we're next in class, I'd like you to really just explore what methods can be used when, so that you're prepared to use any of them when it comes time for an assessment. So we're going to get started. You're going to want to have your calculator because most of these will require some use of technology. So have your calculator available. If you need to pause and grab it, that's great. Okay, so here we are, and we're starting off with 7 to the power of x equals 19. And I can't just compare how a 7 turns into a 19, and that's actually why we have logs. The whole point is that there's going to be times that we cannot just figure it out by any sort of examination or exploration. So I need to say, well, since this is a base with a power and a value, that I'm going to write it log base 7 of 19 equals the exponent. That's the point of logs. From this point, you can use the fancy type in your calculator if you have the new operating system for log base, or you may do the change of base, which is log 19, make sure you close your parentheses, divided by log 7. And that will give you the value. So I'll give you a second, and again, you're either going to use the second, the alpha y equals and get the log base, or you've done the change of base formula already. So log base 7 of 19 has an approximate value, and it is an approximation of 1.513. We'll go to 3 decimal places. So let's just explore. What if we took 7 and we raised it to the power that I just wrote down, 1.513? Am I going to get exactly 19? The answer is no. That's why we want to approximate. That's why this is actually the most exact value you could possibly give me. It's kind of like the square root of 2. Square root of 2 is way more exact than any decimal you could possibly give me. That's like pi. Pi is way more exact than 3.14. But if I am looking for an approximation, 1.53 is a good approximation of what takes a 7 and turns it into a 19. Alright, next one. Same idea. I'm going to say that I have a log with a base of 3. The value of 13 is going to equal the exponent. That's what I'm trying to figure out. This one requires a little bit more algebra, because not only do I have to find this value, I then have to add 5 and divide by 2. So if you're using change of base, you'll do log base log 13 divided by log of 3. Okay, and that's going to equal 2x minus 5, which means you take this value, you add 5, and whatever you get, you divide it by 2. Alright, go ahead and try that and let's see what you get. So if you tried to enter that all at once, you might not have gotten the correct answer. So the correct answer should be 3.667. That's an approximation anyway, so 3.667. Again, if you tried to, I would press enter before you divide by 2 if you're going to try to enter all of this at once. Otherwise, the only thing you're dividing by 2 is the 5. So that's the reason. Okay, the next one. So here we have a base of e. So I could write this as log base e of 12 equals 2 minus x. But remember, log base e is the natural log of 12 equals 2 minus x. So this requires one button, natural log of 12, hit enter, and it looks like I'm going to have to subtract 2 from that value on my screen, and I'm going to have to divide it by -1. And the outcome is x is approximately -0.485. I'm rounding to 3 decimal places there. Alright, number 4 looks a little bit different. This one's going to require me to use exponent properties to condense it first. So since I get to add my exponents, I'm going to end up with e to the 7x. And this one equals e to the 21st. Well, since they both have a base of e, that means that 7x must equal 21 and x must equal 3. That one didn't require any technology. Okay, so now I have some logarithmic equations. This first one starts very similar to the last one that we did with exponents, and that is that if I have a log on one side and a log on the other side that are exactly the same base, in this case they're both natural logs, that I am able to then just solve for the values. Because the natural log with this value and a natural log with this value, if they're equal, the values themselves must be equal. This actually becomes a very simple problem. X equals -5. Okay, the next one, not as easy. Not that it's difficult, but it does require a little bit more. In this case, I want to gather the x's on one side. So the first step is to gather the x's, as in the logs. Gather the logs on one side and condense the expression. This is when we needed to know the log properties. So I'm going to move this log of x plus 3 to this side and leave the 3 over there. When I condense these together, I get log of 11x plus 9 over x plus 3, because it's the two values that get put on top of each other, and it's division because I see subtraction. And this still equals 3. You say, well, now what? Well, ask yourself what this base is. This base is 10. That means 10 to the power of 3 equals 11x plus 9 over x plus 3. We are going to be able to solve this using cross multiplication. So this is 1,000. So I will have 1,000 times x plus 3 equals 11x plus 9. And we're able to continue and solve this problem. So as you can see that when we finish and solve this, we're going to end up with quite a very small x value. I will have, let's see, 989x plus 3,000 equals 9. 989x equals 2,991. And when you divide, let's see what we get here. 2,991, oh, that's negative, right? Divided by 989 is going to be negative 3.024. And that is our value. Okay, great job. Okay, for these last two, number one in particular is going to require us to do something a little creative. If I had two sides of an equation that I could do the same operation on and be able to eliminate the logs, that would be the exponents, that would be my goal. And that's what I'm going to do. I'm actually going to take the natural log of both sides. I'm going to apply the natural log on both sides. That is that I'm going to take the natural log of 3 to the 2x minus 1 equals the natural log of 0.4 to the power of x plus 2. I'm now going to apply one of my exponent properties, and that is that I can move the exponents in front. So this means I have 2x minus 1 times the natural log of 3. That's exponent times exponent, because logs represent exponents. And then I have x plus 2 times the natural log of 0.4. Okay, I'm going to now distribute this natural log of 3 and the natural log of 0.4. You see, the natural log of any number, or the log of any number, is just like a crazy number. Just like the square root of 3 is a crazy number. So I'm going to distribute, and I'm going to have 2x times the natural log of 3 minus 1 times the natural log of 3 equals the natural log of 0.4 times x plus 2 times the natural log of 0.4. I'm just distributing inside on both of these. Everything with an x gets collected on one side. So that's going to be over here. We're going to put everything that has an x. 2x times the natural log of 3 minus the natural log of 0.4 with an x. And I actually want to write that x in front. Let me do that instead, so that you recognize it's not 4x, but it's x times the natural log. Okay, and then I'm going to move everything that doesn't have it, like the natural log of 3 plus 2 times the natural log of 0.4. So first step was to apply the log to both sides. The second step was to use the exponent property and move it down in front. Then I distributed. Write these words down if it helps you. Take the natural log of both sides. Use the exponent property. Distribute. Put the terms with an x on one side and the terms without an x on the other side. Factor out your x. Now that I factored out my x, everything else is just some really, really ugly number. And x equals the natural log of 3 plus 2 times the natural log of 0.4 divided by 2 times the natural log of 3 minus the natural log of 0.4. That is one ugly number. And we certainly could find its value by substituting it into the calculator, knowing that I would have to close my parentheses before I did division. You're welcome to do that. You're also welcome to leave your answer just like this. All right, the last example definitely requires technology, so I want you to grab your graphing calculator. And I want you to go into the y equals, and I want you to put this side is y1 and this side is y2. So in your graphing calculator on the y equals, you're going to type in e to the power of x. Remember that button is over by the 7, and you have to press the second key. So e to the power of x plus the natural log of x. Just that. Then in y2, I want you to put a 5. Your calculator may have changed windows, so you might want to just zoom 6 and you'll get the best window. But what we're looking at is the first line you see is kind of like this. Okay, and we don't know what goes off the screen somewhere. Okay, but then you also see this. And what we're introducing here is a way of solving by setting one side equal to the other. We're asking ourselves, when do these two things have the same value? So I'm looking for their intersection. And their intersection can be found by using second calc. That's the trace button, just like we use it for max and min and 0. And number 5's option is intersect. Okay, so what they're going to ask for is the first curve. So you use your cursor until you're on this blue, mine's blue because I'm using my new calculator, but when you're on the e to the x line, and press enter. Then it says be on the second curve. So here you're somewhere on this curve. It doesn't matter where as long as you're on the horizontal line. Then it wants you to guess, and you may use the cursor and move it over to where you believe the intersection is. Okay, the outcome is whatever the x value is. That's saying that they intersect when x is 1.522. 522, I'm sorry. 522. This is when these two things intersect. That means that the value of x that you're looking for will give you a 5. We can test it. Go back to your home screen. Type in e to the power of, and this is going to be an approximation, 1.522, okay, plus the natural log of 1.522. And you'll come up with something that's approximately 5. So I'm looking for that x value. This is another option, is using technology to find out when the one side equals the other side. We're using a graph and we're using intersections. Again, there's lots of different methods. Some of them are quick, some of them require some manipulation, some of them, all of these seem to require technology though. Great job.